Hey, this is section 5.3, number 3. It says the number of bacteria in a culture grows according to the formula n of t is equal to n naught times e to the 0.05 t, where n naught is the number of bacteria present at time t equals 0, and t is the time in hours. So we're going to write a growth law for the sample in which 6,000 bacteria were present initially. Okay, and to do this, we're just going to substitute 6,000 for n naught, and it looks like this: 6,000 e to the 0.05 t. Okay, just be careful if you're typing this expression in XYZ homework that you may need to put parentheses around the exponent if you type it like this. And then with the caret. Part B, on your own, make a table of values over the first 30 hours and graph n of t. So I'm just going to use my calculator to help me out. Okay, so in Y1, we're going to enter the function equation. Okay, I'm going to look at my table setup under second window, and the table starts at 0, and the change in table, or the change in our x coordinates, are going to be 1. Okay, we'll be able to see the table if you select second graph. Okay, and then we can just scroll down and see the first 24 hours. And so even answering part C, it says find n of 24. Okay, it's rounded to the nearest whole number. It says it's about 19,921. Okay, but alternatively, we could have just substituted 24 directly into the equation. And so n of 24 is 6,000 e to the 0.05 times 24. And again, we get the same answer. And lastly, in part D, it says how much time must elapse to the nearest tenth of an hour for the original 6,000 bacteria to increase to 100,000. Okay, so using our formula, we're going to let n equal 100,000. So we have 100,000 equals 6,000 e to the 0.05 t. Okay, and we're trying to solve this equation for t. Okay, so one option is to go to our graph, and in Y2 enter 100,000. Okay, and we'll just graph it first using zoom 6. Okay, so then try zoom 0 for zoom fit. Okay, we're going to adjust our x max because I see the exponential function is kind of creeping up at the bottom, but I need it to reach this line at the top of my screen. So let's say that x max is 100. Okay, and then graph again, and hopefully you see the intersection. Okay, next we'll use the intersect feature, so second trace, number 5, and then hit enter 3 times. Okay, and the intersection occurs when x is about 56.3, and that is our t value, so that's what we're going to say. That's in hours. Okay, another option is to use the natural log to solve this equation. So the first thing I'm going to do is to isolate the power, and I do that by dividing both sides by 6,000. And we can simplify this sum, and so we get 100 over 6, or you can write it as 50 over 3. Okay, now we're going to rewrite in logarithmic form. And so we have the natural log. I'm going to use natural log because the base of this power is an e, and the base of the natural log is also an e. Okay, of 50 thirds is equal to the exponent 0.05t. And then divide both sides by 0.05. So we have natural log of 50 thirds divided by 0.05 is equal to t, and we're going to use our calculator. Okay, and evaluate. So natural log of 50 thirds divided by 0.05, which is again about 56.3.